Okay, sure. So, ladies and gents, it's time to start our last session today. We'll have 6 articles here. And the first one is prepared by the team from Poznań University of Technology. And the team is as follows: Maciej Dybizbański, Marceli Hązła, Professor Katarzyna Rzeszut, and Ilona Szewczak. Actually, I believe that Ilona Szewczak is from Lublin University of Technology. The presentation will be delivered by a rookie, Maciej Dybizbański. Maciej, the floor is yours. Take your time.
Thank you very much. My name is Maciej Dybizbański, and I'm a PhD student at the Doctoral School of Poznań University of Technology. I just recently started my scientific journey, so all the critique is really welcomed. Today, I would like to talk about the economic and reliability aspects of thin-walled cold-formed steel structures strengthened with carbon fiber reinforced polymer composites. So, why am I doing this? Well, from day-to-day life, it became more and more noticeable that the prices for many products vastly increased. For example, steel prices. And because of it, there is a need to find an optimal way to reduce the steel consumption. And it can be achieved by extension of the usage of thin-walled steel elements. In our work, the analysis of current state of the market and its future prospects was carried out, as well as the analysis of the possible usage of thin-walled cold-formed steel elements strengthened with carbon fiber reinforced polymer composites. Moving on to the economic research. Well, in Figure 1, the strike prices for steel ton futures on the New York Mercantile Exchange in the past few years are described, and it can be observed that in the span of just 1 year, the prices increased for raw steel. The prices increased by about 260%, which is a huge amount. And based on the review of the literature and the industry media and the market trends, the potential main causes of this may be described as high degree of concentration of steel production. Well, about 70% of global steel production is based just in the Asian region, and about 54% just in China. And because of it, the market is vulnerable to disruption caused by random factors, as it can be seen during the COVID-19 pandemic. Of course, it cannot be said that in the span of following years, the prices will stabilize at the level of 2020. Well, other factors may have an impact. And for example, the prices of European permits for 1 ton of CO2 emissions increased from 2011 to 2021 from about 10 euros to 70 euros. And taking into account that many developing countries are trying to westernize their economies, and the European Union tries to decarbonize their economies, it may have an impact worldwide that the prices finally will stabilize at the higher level than in 2020, than before the pandemic. So, concluding this, the increasing steel consumption per capita per unit of GDP produced influences the increasing dependence of the world economy on steel. Also, the high degree of concentration of world steel production causes the vulnerability of supply chains to disruption caused by random factors. And the need to reduce CO2 emissions in the global economy causes the rising steel production costs. And taking all of this into account, the steel prices are likely to stabilize at higher levels than before 2020, and the market will remain still vulnerable to disruptions caused by random factors. So it can be said that it will be beneficial for companies to reduce their demand for steel. It can be achieved, that reduction, by extending the usage of thin-walled steel elements, which demand less steel to manufacture than the hot-rolled ones. Of course, the biggest problem with open sections of open cross sections made out of thin-walled steel elements is that the strengthening is a very complex problem. Due to the inability to perform welded joints, due to limited ability to apply mechanical fasteners, and its high sensitivity to imperfections and tendency to buckling. So there's proposed new innovative method of strengthening those elements by gluing to them the CFRP tapes. Those tapes are made out of composite material. It's a polymer reinforced with carbon fiber, and those tapes are glued to the elements. And I will show 4 examples of research that's worldwide. For example, there was a research about sigma cross sections strengthened with those tapes, and those elements were subjected to buckling. There was a research where the beam-to-column connection strengthened with 3 layers of CFRP tapes subjected to cyclic loading. And following it, there also were 2 similar researches where the steel hollow sections wrapped around in CFRP tapes were subjected to compression. And the results were as follows. For the bended elements, strengthened bended elements, the vertical displacement can be reduced by up to almost 18%, while the horizontal by almost 45%. For the beam-to-column connection, the bending resistance of such a connection can be reduced by about 41%. And for the steel hollow sections subjected to compression, it was noticed that the reinforced samples were able to transfer 2.6 up to 4 times the value of compressive force until the first local buckling appeared. Conclusions. In the light of the increasing global demand for steel, the vulnerability of the global steel market to distortions arising from high concentrations of production and the rising costs of steel production, it would be beneficial for companies to reduce their demand for steel. And one possible way of achieving this goal is to extend the usage of thin-walled conform elements, and that may be strengthened with CFRP composites on the wider scale. Unfortunately, at present, the number of publications on this matter is very limited, and most of them focus on the analysis of compressed elements. As a result, it is necessary to carry out further research on this subject. Thank you for your attention. Are there any questions?
I have a comment to the question. Comment is that it is good for you that there is only the few papers, because you can write a lot and publish whatever you find out. So that's a good point, rather. But the question is just my curiosity: if application of CFRP increase or decrease consumption of carbon and its presence in the environment, wouldn't it be better to apply GFRP, glass fiber reinforced plastics?
Well, if I recall correctly, the CFRP tapes are wider used than the GFRP. And because of the, what's called in English? In Polish. Są bardziej kruche. GFRP are more brittle than the CFRP. That's why it's better to use the CFRP than the GFRP.
Is there any, let's say, large-scale producer, manufacturer of CFRP in Poland? Well known for us, because we make the same at our faculty, but related to concrete structures. Thank you.
Anybody? Yeah.
One question related to the price of this carbon reinforced strengthening material, yeah, because in my opinion it is much more expensive to use it in terms of comparing to the steel. And how would you refer, and are you planning to compare also the price difference with the capacity increase with both approach?
Thank you very much for this question. Well, I did not yet take into account the prices of those composites. Of course, it may vary in terms, but in the future, I would probably take it into account.
Okay, thank you. I just want to be sure. You don't want to make it this way, that you are using the cold form profiles, and after you are using it, you are strengthening with those tapes. This is for the future, for extra load? All right, thank you very much. Any questions, remarks? Okay, if it was your first time as a presenter during the conference, it was pretty good.
Thank you very much.
Okay, so next presentation is prepared by the team and Maciej Wiśniowski, Krzysztof Kozieł, Leszek Rogoziński. Topic is extremely practical, and I'm very, I'm waiting for your presentation. Okay, so take it on.
How to use this tool? But it's so complex. Okay. So hello, my name is Leszek. I'm here on behalf of the company ODS Gliwice. I came here from Gliwice, of course, and I came here to share our observations regarding the design of corrugated sheet, trapezoidal sheet, in context of